Welcome to Life Changing Tuition's YouTube channel. In this video, I'm going to be going over the maths section in Summer School Booklet 1. The topic in this booklet is fractions. The first question says, Julie has a box of different colored ribbons. 12 are blue, 27 are yellow, 9 are red, and 2 are green. A. How many ribbons does Julie have altogether? This question is quite simple. All we have to do is add up the different colored ribbons. So we have 12 plus 27 plus 9 plus 2. First we can add 9 to 2, and we get 11. And we're left with 12, add 27. Then we can add 11 to 12, and we get 23 plus 27. And finally, adding these two gets us 50. So that's the answer to the first question. B. What fraction of the ribbons are blue? Give your answer in its simplest form. This is quite simple as well. All we have to do is take the number of ribbons that are blue and divide them by the total number of ribbons. That gives us 12 over 50. And we're asked to give this answer in its simplest form. So we can divide the top and bottom by 2, and we get 6 over 25. And that is the answer in its simplest form. We can't divide 6 and 25 by any common factor. Moving on to the second question, the two large right-angled triangles are identical. All internal triangles are similar in shape to the larger triangle. Which is larger, the shaded area in the triangle on the left or the shaded area in the triangle on the right? I'm going to label the two triangles. I'm going to call the triangle on the left L and the triangle on the right R. Okay, so let's take a look at the triangle on the left. We can see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9 triangles. And we can see that 1, 2, 3, 4, 5, 6 of them are shaded. This means that 6/9 of the first triangle is shaded, since all of the triangles are identical. Now if we take a look at the second triangle, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 triangles. And since I counted the shaded ones first, we know that 10 out of these 16 are shaded. Now we can simplify this further, and we can get 5 out of 8. Now, in order to find which of these two fractions is bigger, we have to get them both into decimal form. And the way we do this is by doing a simple division. So if we take the first fraction, 6 over 9, all we have to do is put 9 on the outside and 6 on the inside. We know that 9 goes into 6 0 times, but it goes into 60 6 times. And since 9 times 6 is 54, that leaves a difference of 6. And we know that again, 9 goes into 60 6 times, and it leaves a difference of 6. So we know that 6 over 9 in decimal form is equal to 0.6 recurring. Now if we just repeat this same operation for 5 over 8, we have 8 on the outside and 5 on the inside. Now we know that 8 goes into 5 0 times, but it goes into 50 6 times. And 8 times 6 is 48, and that leaves a difference of 2. Now 8 goes into 20 2 times, and 8 times 2 is 16, which leaves a difference of 4. Finally, 8 goes into 40 5 times, exactly, and then that gives us our answer of 0.625, which is equal to 5/8. Now we can see that 6/9 is bigger than 5/8 because 0.66666 is larger than 0.625. So to answer the question properly, the triangle on the left has a greater shaded area than the triangle on the right. Let's have a look at question 3. Evaluate the following fractions, giving your answer in its simplest form. 1/4 plus 1/3 minus a half. Now, in order to add and subtract fractions, we have to make sure all of the denominators are the same number. And the way that we would do this is to find the lowest common multiple of 4, 3, and 2, which happens to be 12. In order to get 1/4 with a denominator of 12, we can multiply the top and bottom by 3, since 4 times 3 equals 12. We can do the same thing for 1/3, and we'd have to multiply the top and bottom by 4, since 3 times 4 is equal to 12. Finally, when we do it for half, top and bottom by 6, since 2 times 6 is 12. Now we can go ahead and add and subtract these fractions. So what we have is 3/12 plus 4/12 minus 6/12. 3 plus 4 minus 6 is equal to 1, and so the answer is 1/12. Moving on to question 4. Evaluate the following fractions, giving your answer in its simplest form. 2/5 divided by 6. Now we know that when it comes to dividing fractions, it's essentially the same as multiplying fractions but flipping the second fraction. So if we turn this into a fraction, we have 2/5 divided by 6/1. Now if we want to change this into a multiplication, all we have to do is flip the numbers of the second fraction. So we have 2/5 multiplied by 1/6. We can simplify this by dividing by 2, and what we have left is 1 times 1 and 5 times 3, which is 1/15. And question 5. Place the following fractions in the boxes below by arranging them from smallest to largest. 7/18, 4/9, 5/12, and 1/3. Now, just like question 3, we have to find the lowest common multiple of all of these numbers to make sure that they have the same denominator, and that way we can easily see which fraction is greater or smaller than the other. In order to find the lowest common multiple of 18 and 12, we can simply write out their times tables and see which is the first number that lines up. So we have 18, 36, and we have 12, 24, and 36. And we can see that 36 is in both of their times tables. We also know 36 is in the times table of 9 and 3. So what we have to do is turn all of these denominators into 36. If we start off with 7/18, if we want to get that to 36, we can multiply the top and bottom by 2, and that gives us 14/36. If we then take 4/9, and we want to get that over 36, we can multiply the top and bottom by 4, since 9 times 4 is 36. 4 times 4 is 16. If we move on to 5/12, in order to get that over 36, we can multiply top and bottom by 3. 5 times 3 is 15. And finally, if we take 1/3 and we want to get it over 36, we can multiply the top and bottom by 12. since 3 times 12 is 36. Now, if we compare all of these fractions, we can see that 16 over 36 is bigger than 15 over 36, which is bigger than 14 over 36, which is bigger than 12 over 36. So, 1/3 is the smallest fraction, 7/18 is the second smallest fraction, 5/12 is the third smallest fraction, and 4/9 is the biggest fraction. So, if we were to arrange these fractions from smallest to largest like the question asks, we would put 1/3 first, and then 7 over 18, and then 5 over 12, and finally 4 over 9. Moving on to question 6. Convert the following fractions to decimals. A. 3/10, B. 17 over 50, C. 14 over 20. Now, the last time we were converting fractions to decimals, we did a simple division, but in this case, we can do it even easier because most of these are all multiples of 10. So if we look at the first fraction, 3 over 10, we know that when we divide by 10, all we have to do is move the decimal point to the left. So we have 3.0, and if we're dividing by 10, we move the decimal point here, and we're left with 0.3. If we look at the second part of the question, 17 over 50, we can convert this into a percentage by multiplying the top and bottom by 2. This gets us 34 over 100, since 17 times 2 is 34. Now we use the same trick that we did in the last question, and we move the decimal point back 2 places. So 1, 2, and our answer is 0.34. Finally, for 14 over 20, we can multiply the top and bottom by 5 to get the fraction over 100, and 5 times 14 is 80. So if we take 80 and we move the decimal point back 2 spaces, we are left with 0.8. Now, question 7 says, shade in 3/8 of this shape. Now we can see that there are 1, 2, 3, 4, 5, 6, 7, 8 blocks along, and we can see that there are 3 blocks down. So if we shade the shape 3 blocks of the way in, if we're going across, then that basically answers the question, as we've shaded 3/8 of the shape in. If we move on to question 8, Neil spends 1/3 of his money. He then spends 1/3 of what he has left. What fraction of his money did he spend altogether? To work out the answer to this question, we have to remember that of means times. If Neil spends 1/3 of his money, then that means he has 2/3 left, since 1 minus 1/3 is 2/3. And if he's spending 1/3 of what he has left, remembering that of means times, all we have to do is multiply 2/3 by 1/3, which leaves us with 2/9, and that's the fraction of his money that he spent altogether. Question 9. What is half of 1/3 of a quarter? So we know from the previous question that of basically means times, so all we have to do is multiply all of these fractions together. So we have half times 1/3 times a quarter, and if we just multiply the denominators by each other, we get 1 over 24, and that's the answer to question 9. Number 10. David has a square piece of card. He cuts off the areas which are shaded, as shown in this diagram. What fraction of the original area is now remaining? So if we see the square piece of card has been divided into 4 equal areas. 1, 2, 3, 4. So each of these areas are its own square, and we see that in squares 2, 3, and 4, half of it has been cut off. So what we're left with is a quarter here, half of a quarter here, half of a quarter here, and half of a quarter here. All we have to do is add all of these fractions together after finding out the multiplications. We know that half of a quarter is an eighth, so we can fill these in, and then we just add the fractions together. We have 1/4 plus 1/8 plus 1/8 plus 1/8. So we have 1/4 plus 3/8. Now to add the fractions, we have to make the denominators equal. So we can turn 1/4 into 2/8. And if we add that to 3/8, we get 5/8. That is the answer to question 10. Now if we look at question 11, it says, work out 3 1/10 times 5. 3 1/10 is what's known as a mixed number. And in order to convert a mixed number into an improper fraction, we have to multiply the denominator by this big number and then add that to the numerator. So we have 31/10. And if we want to multiply that by 5, all we do is multiply 31 by 5 and 10 times 1. And what we're left with is 155/10. If we want to turn that into a decimal, that would be equal to 15.5. And if we wanted to turn it into a mixed number, we can simply do a division. 10 on the outside, 155 on the inside. We see that 10 goes into 15 once, with a remainder of 45, and 10 goes into 45 4 times, with a remainder of 5. So what we do is we put 14 on the outside as the big number, because 10 goes into 155 14 times. We put 5 at the top and 10 at the bottom. And that is our answer to question 11. Moving on to the last few questions. Question 12 says, what is 0.15 as a fraction in its lowest terms? Now, if we multiply 0.15 by 100, we get 15. And if we divide that by 100 again, we would get 0.15, meaning 15 over 100 is equal to 0.15. Now, if we want to simplify this fraction, we can divide both sides, top and bottom, by 5, which leaves us with 3/20. Question 13 says, what is 1/3 of 414? Now, of means times, so all this is saying is 1/3 times 414, which is equal to 414 over 3. So in order to carry out this division, we put 3 on the outside and we put 414 on the inside. We know that 3 goes into 4 once, with a difference of 1, and 3 goes into 11 3 times. 3 times 3 is 9. The difference between 11 and 9 is 2. And 3 goes into 24 8 times. So the answer to this question is 138. Question 14 says, if 2/3 of a number is 24, what is 3/4 of the same number? So what we have to do first is find the original number. We are being told that 2/3 of some number n equals 24. Now what we have to do is isolate this number n, and we can do that by dividing both sides by 2 and then multiplying by 3. So if we divide both sides by 2, we are left with 1/3 n equals 12. And then if we multiply both sides by 3, we are left with n equals 36. And that is the original number. Now we have to find 3/4 of this same number. So we have 3 over 4 multiplied by 36. We can first simplify this by cancelling out the 4 with the 36. 36 divided by 4 is 9, and 3 times 9 is equal to 27, and that is the final answer. Finally, question 15 says, what fraction of each shape is shaded? We can see that in shape A, the circle is split evenly into 5 different sections, and we can see that 2 out of these 5 sections is shaded, meaning that 2/5 of the shape is shaded. In B, we have a square that's split evenly into 9 different squares, and we see that only 4 of these squares are shaded in, meaning 4/9 of the shape is shaded in. Finally, in question C, we have a rectangle that's split into 6 different equal rectangles, and only 1 of these rectangles is shaded. So that means 1/6 of the shape is shaded. That was the final question in this booklet for the maths section. In the next video, I'm going to be going over summer booklet number 2 in the same way. Thank you for watching, and I'll catch you guys next time.